everyone. In today's video I will be solving a problem based on moment area method, and this will be our problem number 2. So problem number 2 for a cantilever beam. Okay, so now for a cantilever beam, so we know that for a cantilever beam one side is fixed and the other side is free, and this type of beam is known as cantilever beam. So in this problem, in this beam, what happened, the UDL load is acting, UDL load of W. Here, from here to here distance, let it be L, and this point will consider as A and this point as B. So in moment area method, first and foremost step is to find the bending moment diagram. So here let's draw the bending moment diagram. Okay, so now bending moment diagram for a UDL for A point, and this one is B point. So bending moment at B will be 0. So bending moment here at A point will be W L square by 2. Okay, so it will be somewhere here, and the shape of the here in this beam UDL load is acting. So if UDL load is acting, then the shape will be a parabolic. If suppose here it's a point load, here point load is acting, then the bending moment diagram will be a straight line. Okay, but in this case in UDL the bending moment diagram will be a parabolic diagram. So how to get this value, as we have already solved in our strength of material subject, so no need to explain only, but I'll explain you here. Okay, this part. So here how to find bending moment at B first. Okay, at this point bending moment is always load into distance. Okay, here at this point this UDL load is acting, right? Suppose it's a W into here at this point, what is the distance? We have to find the load at this distance at B. So here it will be 0. So ultimately we'll get the value here is 0. Now we have to find for the bending moment at A. So what will be the value? Same, load into distance. Load is W, and from this side how much distance is covered? It's L distance into L. Again we have to convert this UDL into point load. So what we have to do is into half of the L, half of the distance. Then what will get? W L square by 2. Okay, and here it's always negative, so here also you have to put negative sign. Okay, so this is bending moment diagram. So now next step is to find the M by EI diagram. Suppose in this question EI is not given, right? So we'll keep the value of EI as EI only. If some values is all given in the question, then we have to put the value for EI in the particular wherever it's required. Okay, so now we have to draw the M by EI diagram. So here the diagram for the bending moment and M by EI diagram will be same. It's a parabolic. So here W L square by 2 EI, we have to divide by EI. So it will be M by EI diagram. Okay, now the next thing is we have to draw the elastic curve. So elastic curve for this beam will be like this. It's a and B, it will be like this, and one tangent will be there, and this will be slope at B, and this is the deflection at B. Okay, it's a elastic curve. Now we'll start with the problem. Here we have to find in the moment area method we have to find the slope as well as deflection for this type of beam. Now we'll start with the slope. That is the first theorem. Okay, first theorem is used for finding the slope, and slope is denoted by this theta term. Okay, now here we have to find the slope from B to A. Okay, if we'll go with B to A, then how we have to write? Slope at B minus slope at A is equal to area of M by EI diagram. So this is the formula of finding the slope. M by E diagram is this one. Okay, and it's always its negative sign. So M by E diagram. So area of M by E diagram. Here see, it's not a triangle. Okay, so it's a parabolic. So in my previous video I have explained you about the how to find the area for this type of beam. So suppose this is a parabolic, right? So to find the area, here to find the area, what is the formula? That is 1 by 3 into h into L. This is the formula for finding this type of. So now we have to write 1 by 3 into h into L. Now 1 by 3, what is L here? H here. H is this one, WL square by 2EI. WL square by 2EI, and L base. So it will be L only. So what we'll get is equal to, here see, this one, so here theta B minus theta A here it will be 0. So theta A value is 0. So here theta B is equal to 1 WL cube by 3 to the 6EI, and it's all negative. Okay, it's a negative. So now this is the value for slope at B. Okay, now we have to find the deflection. So write second theorem, and second theorem is used for finding the deflection, and this deflection is denoted by the term this or theta, like this. Okay, so now we'll find the deflection. So here deflection at B, right? So we have to find the deflection at B. So deflection at B, the formula is moment of M by EI diagram at B. Okay, we have to find the moment of deflection of B at deflection at B point. So it will be from the B side. Now moment, we know that how to find a moment. Moment is nothing but area into CG distance, right? So what is the area for M by EI diagram? As I have already mentioned here also, that is 1 by 3 of h into L. 1 by 3 into h into L, right, into CG. So now how to find the CG? For I'll write down here. Okay, for this type of, here suppose CG is acting at the center. So from it's a and B, from B side here up to this distance is 3 by 4 of L, and from this CG to the A is 1 by 4 of L, and it's very important to remember those. Okay, in my previous video also I have uploaded those important formulas which we have to remember. Okay, so you can go and check it out in my previous videos. Now this is the area and CG distance is 3 by 4 of the L. So now we have to put here 1 by 3, and H value is nothing but, what was that, WL square, this one. Okay, WL square by 2EI, WL square by 2ei into L will be L into 3 by 4 of L. Now this 3 and this 3 will get cancelled and remaining we have to simplify it. So now it will be WL L square to 4 to the power 4 divided by 4 to the 8 ei, and don't forget to put this negative sign here. Okay, these are all negative. So deflection at B is equal to minus WL to the power 4 divided by 8 ei. So this is the deflection at B. So this is the steps which we have to follow to find the slope and deflection for this type of beam. Okay, thank you.